Okay, this is lesson 5.4. This is about rational exponents. So what rational exponents are is rational means like a fraction. You can look at the root, it means ratio. So anything that can be written as a fraction is rational. So we're talking about exponents that are fractions is really what we're talking about when we're talking about rational exponents. So fraction exponents work like this. If I have the square root of 5, remember if I don't have any root, it's the square root, so there's no index there. So that means the square root, which means you treat the index like 2. So when I have an index of 2, the square root of 5, as I write that as a rational exponent rather than a radical expression, becomes 5 to the 1/2 power. 7 becomes 7 to the 1/3 power if it's the cube root of 7. So usually that's enough to get the idea of the pattern now. The index just becomes the bottom number of the fraction. So the 4th root of 12 is going to be 12 to the 1/4 power. Now, when we get a little bit more complicated, when you have a number that doesn't have a 1 on top, you're going to have to be able to go back and forth between radical form and rational exponents. And we do this, remember, the bottom number of the fraction, we already said that was the index. So it becomes 5 on the outside. That 3 on top of the fraction becomes an exponent that goes with the variable or the number, whatever it is we have raised to a rational exponent. That exponent can go inside the radical bar or outside the radical bar. It doesn't matter. You'll get the same answer. It'll be the same way. So you can either put the 5th root of x to the 3rd power, or you could write x to the 5th root of x and then raise that whole thing to the 3rd power. Both ways are right. And then I go the other way. I'll get there. There we go. Going the other way, when we start with a root and we need to get a rational exponent. Okay, again, the index goes in the bottom of the fraction. In this case, since there's no index, the index is understood to be 2. The exponent stays on top of the fraction. So 3, the index goes in the bottom over 2. So that is a to the 3 over 2 power. So obviously it's okay to have an improper fraction as a rational exponent. See where the 3 is bigger than the 2, the numerator bigger than the denominator in this one. That's okay. Okay, so here's a few examples. Now, the first thing we have is y to the negative 3/8, and that's going to throw a wrench into what we're doing right away because it's a negative number, and we haven't seen too much of negative exponents. In fact, it comes up later in our lessons where we deal with actually teach you about negative exponents. But for the time being, I'm going to run the negative exponents like that. Anything that has a negative exponent, that exponent just gets moved to the bottom of a fraction. So y to the negative 3/8 is the same thing as 1 divided by y to the 3/8. You take away the negative on the fraction and on the exponent, and it becomes, and the whole thing moves to the bottom of the fraction. So this is 1 divided by y to the 3/8. So what is y to the 3/8? Well, that's going to be, the 8 is going to be the index on the outside, and the 3 is going to be an exponent with the y. And again, I said that goes on the bottom of the fraction because of a negative exponent. So that's 1 divided by the 8th root of y to the 3rd. The second one's tricky for a different reason, and that's because it's written as a decimal. I can't move a denominator and a numerator if I don't have a denominator and a numerator. So I have to convert 0.4 to a decimal first. So 0.4 is also 4/10. That's the way you'd say it. So it's 4 over 10. And then I simplify that fraction because they both divide by 2. That gives me 1 over 5. So this is z 2 over 5. This is z to the 2 over 5th power. Now, when we deal with that, that means the 2 is the exponent and the 5 is the index. And so I write it like that. Now to move to exponential form, this is much simpler. I have the cube root of x to the 2nd. So that means the 2 goes on top and the 3 goes on the bottom. And then I have the square root of y to the 3rd, which means the 3 goes on the top and the 2 goes on the bottom. Remember, if there's no index written, the index is understood to be 2 because it's squared. These are some examples you could use in a calculator. When you use a calculator, you have to use the button. It comes right underneath of clear. It looks like a little arrow that points up. That's the power button. And the most important thing to remember when you use the power button is that the fraction that you're raising it to has to be in parentheses. So if I try to raise 125 to the 2/3 power, I have to make sure that 2/3 is in parentheses, because if I don't put 2/3 in parentheses, what the calculator does is 125 to the 2nd power and then divide the answer by 3, because exponents come before division in the order of operations. So you have to make good use of parentheses. When in doubt, use parentheses in the calculator. All right, so the rules we used with exponents before still apply to exponents even if they're fractions. So number 1, well, there's actually both 2 number 1s, but the first one with the 5s, that's 5 to the 1/2 times 5 to the 1/2. Now when you have the same base for the exponents and you multiply them, what you really do there is add the exponents. So if I had, x squared times x to the third, I would add the 2 and the 3 and get 5. That would be x to the fifth. This is 5 to the 1/2 times 5 to the 1/2. So what I do is I do 5 to the 1/2 plus 1/2, because I add them up. I just put them into one exponent and add them up. 1/2 plus 1/2 is, of course, 1, so that's 5 to the first, and 5 to the first is just 5. So when I simplify that, the answer is 5. The second one, 4 to the 1/4 to the fourth, when I have a power raised to a power, you multiply the numbers together. So this is going to be 4 to the 1/2 times 4, and 4 times 1/2 is 2. So that's 4 to the second, and 4 to the second is 16. Okay, sometimes we want to be able to simplify with rational exponents. There's two ways to go about this, two schools of thought. One way is to convert the negative 32 to the 3/5 power, convert it into a radical. So that would be the 5th root of negative 32 to the 3rd power. And if you do it this way, you want to make sure that 3rd power, remember I told you it can go inside or outside, you want to make sure it goes on the outside. It's going to make your life a little bit easier. But I'm going to solve it the first way. I'm going to do the negative 32 to the 3/5 power without changing it to a radical. And the goal here is to change that negative 32 into a number raised to the denominator of the exponent. So it has to be, in this case, because the denominator is 5, I want to be a number raised to the 5th power. So if I think about it and I test and try different things, I'll find that negative 32 is actually negative 2 to the 5th power. Be careful, it's not 2 to the 5th power, and it's not 2 to the negative 5th power. It's negative 2 to the 5th power. So now I have negative 2 to the 5th power, and then that in turn raised to the 3/5 power. And we just did on the last page, that means you multiply those two numbers together. When I do that, I get negative 2 to the 5 times 3 over 5. When I multiply 5 times 3 over 5, the 5s are going to cancel out. All that's going to be left is the 3. So that becomes negative 2 to the 3rd power, which is negative 2 times negative 2 times negative 2, which is negative 8. Similarly, on the other side, I would do what we did before to simplify negative 5 5th root of negative 32. I'd make it negative 2 to the 5th power, and then I'd cancel out the 5s. That would leave me negative 2 to the 3rd, which is still negative 8. Another example, when we have fractions involved, a decimal involved, which means the first step is to change that decimal to a fraction. So this is 3.5, which is 35 over 10. And when we simplify that, it is 7 over 2. So this is 4 to the negative 7 over 2. Remember, the negative just means that it's going to go into the bottom of the fraction. So it's going to be 4 to the 7 over 2, but that 7 over 2 is going to go in the bottom of the fraction. But again, I want to change the 4 into something that matches that has an exponent that matches the 2. So I can rewrite 4. Oh, I could also write square root of 4 times to the negative 7th power. Sorry, there's going to do both. So this becomes 2 squared, which is 4, to the negative 7 over 2 power, which means it's 2 to the power of, and I multiply the numbers together, 2 times negative 7 over 2. The 2's cancel out. That means it's 2 to the negative 7th. Remember, 2 to the negative 7th is the same thing as 1 divided by 2 to the 7th. 2 to the 7th is 128, so that's 1 divided by 128. Now we have the 4. The other side, the other way we can do it, straight with radicals. The square root of 4 is 2. 2 to the negative 7th, we just said, was 1 over 128. Okay, one more example of this. This one has a variable in there, so it gets a little bit more tricky. So I have 16y to the negative 8th to the negative 3/4 power. So both the 16 and the y to the negative 8 are raised to the negative 3/4 power. So I'm going to have to multiply that 3/4 to both exponents. But I want to change that 16 to have an exponent of 4 to match the denominator of the rational exponent. So 16 I can rewrite if I test and try and do, it's 2 to the 4th power. So 2 times 2 times 2 times 2 is going to give me 16. So now I have 2 to the 4th power times y to the 8th power. And I'm going to have to raise each of those to the negative 3/4 power. When I do that, I multiply the exponents. So I have 2 to the 4 times negative 3/4 times y to the negative 8 times negative 3/4. Now 4 times negative 3/4, the 4's cancel out, and what we're left with is negative 3. And not y to the negative 8th, since it's two negatives, you get a positive. 8 times 3 is 24, and 24 divided by 4 is 6. So what I have here is 2 to the negative 3rd times y to the 6th, and 2 to the negative 3rd is the same thing as 1 over 2 to the 3rd, so that's 1 over 8 and then we multiply 1 over 8 times y over 6, and we get y to the 6th times 8 over 8. Okay, the last thing we're going to do is solve radical equations. Now I'm going to solve these using our rational exponent method, because that's what we're learning today. So the first thing I want to do is change any radicals into rational exponents. So this one's going to change into 2, and then remember it's square root, so it's an entire value that's underneath the bar raised to the 1/2 power. Now I can't FOIL that out or anything, but so we're just going to leave it as it is. But I would like to get that rational exponent by itself. And right now it's not by itself because the plus 2 is with it. So I have to minus 2, so I have to subtract 2 from both sides. That gives me that 3x minus 2 raised to the 1/2 power equals 4. So now I have to get rid of the 1/2 power. And the way I'm going to do that is I'm going to raise both sides of the equation to the reciprocal of a fraction. So if the fraction is 1 over 2, the reciprocal is when you flip the fraction, that's 2 over 1. So I'm going to raise both sides to the second power, because that's 2 over 1. So I have 3x minus 2, and you'll notice here the 1/2 times the 2, that cancels out because it's a 1. That's the first power, and we don't have to write first power. And then on the other side we have 4 to the second power because I have to raise both sides to the same power. So that gives me 3x minus 2 is 16 because 4 squared is 16. But I'm not done yet because x is not by itself. So I have to add 2 to both sides. Gives me 3x equals 18, and then divide by 3. That gives me that x equals 6, and I've solved that radical equation. Another example of a radical equation that's a little more complicated because there's a squared and a third and a cube root involved. So I'm going to take the same steps. I'm going to change that radical into a rational exponent. So 2 goes on the top because it's an exponent, and 3 goes on the bottom because it's an index. So I have 2 times x minus 2 to the 2/3 power, and that equals 50. The next step is to get that rational exponent by itself, so I divide both sides by 2. So now I have x minus 2 raised to the 2/3 power, and that equals 25. So now I have to raise both sides to a power that's going to cancel out with 2/3. And the number that cancels out with 2/3 is its reciprocal, 3 over 2. So I have, going to raise both sides to the 3 over 2 power. On the left-hand side, the 2's are going to cancel out, the 3's are going to cancel out. So I'm going to have first power, so I'm just going to have x minus 2. And on the right-hand side, I'm going to have to simplify that. So I'm going to change that one back to a radical. So it's going to be the index is going to be 2, and the exponent is going to be 3. So when the index is 2, I don't have to write it, so it's the square root of 25 raised to the 3rd power equals x minus 2. So the square root of 25 is 5, and then when I raise that to the 3rd power, I get 125. So that means x minus 2 is 125, which means x is 127. But wait, we're not done, because we skipped one very important thing, and that's when we took the square root of 25. I said the square root of 25 is 5, and that's correct, but it's only half of the answer. You also have to remember that the square root of 25 could also be negative 5. And if we use the square root of 25 as negative 5, then negative 5 to the 3rd power isn't 125, it's negative 125. So we have to consider both answers. So x minus 2 could also equal negative 125, and if I add 2 to both sides of that, I get negative 123. It's really important to remember to get both answers when you take a square root of a number in the process of solving the equation. So that's all I got for you today. Here's your homework. I'll leave it up there for a second. Good luck to you, and I'll see you next class.